Hey everyone, in this video tutorial you'll learn how easy it is to add a search functionality to the GitHub repos that we have built in the previous video. If you haven't watched it yet, please make sure that you check it out, the link is down in the description. Here we have a search field and we can use it for searching for GitHub repositories. Let's say that we want to find RxSwift. As you can see, we're presented with load indicator and then immediately we've got the results for RxSwift, or let's say we want to search for RxDart. So the first thing that we're gonna build is this search field, so let's do it. Here in this widget we need access to IntelliJ and design system, so let's import them. Then we need to listen for text changes, so we need a text editing controller. Let's now build the widget itself. Now it's the right time to emphasize that here we have design system, which means that in the widget itself we shouldn't have any color, icon or style. So how we can get access to the design system? We have an extension method on the context. The same as with the colors, we don't want to have any hardcore strings here, which means that we're going to use IntelliJ plugin for dealing with texts. What we need to do, we need just to go to the Arab file, and here we need to place our string. First we need to specify the key, and then we need to specify the value. Once we have fired your strings, then just run the application, and the Android Studio will take care about generating all necessary code. Then go to your widget, and then you can see that here we have search repos, which is automatically generated by IntelliJ. Just hover over and you can see that this message translates to search for a repo. You can improve the readability of your widgets by breaking down some of the components. For instance, here I have extracted build box decoration in a separate method. Alright, our search bar is ready. Let's now integrate it into the page itself. For adding the search bar on top of the list, we're gonna use nested scroll view. If you're not familiar with this widget, please make sure you check the documentation. Here you can find a lot of information like motivation, some samples, etc. Alright, now the URL layer is ready. We can see that we have a field, we can tap on this field, we can scroll, and the field will scroll along with the list. And if we try to put refresh, we can see that here appears the loading indicator. Alright, let's build our business logic. Every time you start working on your blocks, just make sure that you have started build runner watcher. Once the watcher has been successfully started, we can start implementing our business logic. So what we're gonna do, we need to extend our load page, which is part of our events. Currently we have just one parameter, which is called reset. But what we're gonna need hard reset, which means that as soon as we stop writing and we're performing HTTP code to the GitHub repositories, we need to show a loading indicator here. So let's do it. And now, because load page has more than one parameter, the generator has created a brand new class, which is called load page event Rx. This class resides in the generated file and basically combines reset and hard reset. And now we need to declare another event that will be handling the actual search. The type of the event, it will be behavior subject because we need to get its value. When the user is typing on the field, the URL will be calling filter by query by providing the actual string. And when the user pulls to refresh or loads the second page, the URL will be calling load page. But be aware that our data layer requires all the data from both events, which means that we need to create a dedicated module for this operation. Now we have two events and one model that can grab all the data from the event. So now we need to map load page events to the model that we have created. To improve the readability, we can refactor this to a custom operator. Now we have created a custom operator and we call that operator on a stream. Alright, now we have a stream of GitHub search query, and instead of starting with true, we need to start with an instance of that object. Alright, now we have mapped load page events args to a paginated search, and then we start with defaults. Which is great, but still we want to implement a serial feature, right? And basically we need to get the data either when we call load page or when we call filter by query. And let's see how the reactive programming can help us. So for this operation we're going to use the merge operator. The first stream, it will be about handling put, refresh and infinity scroll, and the second stream it will be handling search query. Basically what does this operator does is that it merges the events flowing to both streams into a single one, and no matter whether we are searching or we are dealing with put, refresh and infinity scroll, this will be our trigger to get the data from the API. So let's merge both streams. To improve the readability of the code, let's now create a custom operator. So let's recap what we have done. We have two events. The first one is load page event, which is of type load page event arguments, and we map this stream to a GitHub search query. Then we have the second event, which is filter by query event of type string, and we map that stream to a GitHub search query. Then we start with default so we can present the data immediately when the user opens the page, and then we fetch data. Here we have access to our model that we have created, which means that we have access to reset, hard reset and to actual query. We take advantage of extension methods and we have created a custom operators on a stream. We have start with defaults, we have map to paginated search on two types of streams. The first one is load page event arguments and the second one is on string. And because we don't want to overload the server with too many requests, we use the bounce time, which will wait until the user stops writing, and at that moment will emit an event. Let's now expose the search query and then we can bind the URL layer to the business layer. Now we need to wrap the search bar with Rx text form field builder. By using Rx text form field builder, we need to provide the actual block that we're interested in. Then we need to provide the state, in our case it's the search query. Then we need to provide the show error state. In this case we don't want to show any error on the field. Then on change we just call filter by query, which is part of the event, and then we provide a builder where we wrap the search bar, the actual widget which is on screen. And this is it, we have implemented search functionality in our GitHub search under 10 minutes. I hope that this tutorial was helpful to you, and as always, the link to the source code is in the description below. Have a nice day and see you next time.